Way out in the constellation Ophiuchus, there's this massive, glittering ball of ancient stars called Messier 62. Now, at first glance, you might think, okay, another globular cluster, but trust me, this one is hiding some incredible cosmic secrets that are totally changing how we think about the lives of stars.
And really, it all comes down to this one question. What happens when you take a giant ball of stars and put it a little too close to the chaotic, supermassive heart of a galaxy? Well, you get a story of incredible gravity, cosmic tug-of-war, and a star cluster living life right on the edge. So here's how we're going to break it all down. First, we'll look at what makes this cluster such an oddball. Then we'll figure out why it flickers. After that, we'll dive into its surprising family history. And finally, we'll tie it all together to see what it means for us. All right, let's jump right in. What exactly makes M62 stand out from the crowd? Because it is not your average ball of stars. So, meet Messier 62. This thing is a real heavyweight, one of the brightest and most massive clusters we know of. But its location? That's what sets the whole story in motion. See, most globular clusters hang out way in the quiet suburbs of the galaxy. M62? Nope. It's living deep in the chaotic downtown, right on the edge of the Milky Way's central bulge. And you know, all these weird properties are totally connected. Its brightness tells you it's massive. Its location near the galactic center means it's getting squeezed by gravity, which gives it that weird distorted shape. All the cosmic dust in that crowded area makes it look redder than it actually is. And this chaotic environment, it's the perfect breeding ground for really exotic stuff, like millisecond pulsars. These are super dense, spinning stellar corpses. And this is where things get, well, kind of stretched. The galaxy's core pulls harder on the side of M62 that's closer to it than the side that's farther away. This difference in pull is called tidal distortion, and it literally stretches the whole cluster out. So instead of a nice, neat sphere, it's visibly elongated. It's basically a scar from living in a really tough neighborhood. Okay, now for the part that gives M62 its awesome nickname, the flickering cluster. And this isn't just some poetic description, it's something very real, something happening deep inside its core. That flicker comes from a very special kind of star called an RR Lyrae variable. Think of them as old, unstable stars that can't help but pulsate. They expand and contract, brighten and dim, over and over, just like a cosmic lighthouse. And because we know exactly how bright they're supposed to be, they are unbelievably useful as standard candles for measuring huge distances across the universe. And here's the kicker. M62 is absolutely stuffed with them. A 2010 study found a staggering 224 of these flickering stars inside the cluster. And that's not just a lot. That is a truly mind-boggling number. To put that into perspective, just look at this. The cluster that holds the record for the most RR Lyrae stars is M3 with 230. M62 is right on its heels with 224, easily beating out other giants like Omega Centauri. It is a photo finish for the title of Most Crowded Field. In fact, the astronomers who did the count basically said, hey, we didn't even survey the whole cluster. They think that if they could do a full census, M62 might actually take the crown. So we could be looking at the real undisputed champion here. Okay, so M62 is warped and it flickers like crazy, but the mystery goes even deeper. It turns out when you actually look at the individual stars, you find this story of a divided family. You know, the classic idea of a globular cluster was pretty simple. One giant cloud of gas collapses and boom, all the stars are born at the same time from the same stuff. One big happy family. Well, M62 and a few other clusters like it have completely shattered that simple picture. And this right here is the proof. It's called a color magnitude diagram. It's basically a star census, plotting their brightness against their color. In a simple cluster, you'd see one nice, crisp line of stars. But look at M62. There's a clear split, a double main sequence. This is the smoking gun that tells us there are two totally different populations of stars living side by side. So what's the difference between these two groups? Well, it all boils down to chemistry. One group, about 79% of the stars, has the normal amount of helium you'd expect from the dawn of the universe. But that other 21%, they are way more enriched with helium. This points to a second, later wave of star birth from gas that was polluted by the ashes of the very first generation. So we've got a distorted, flickering cluster with a complex family tree. But what's the big deal? Why does this all matter? Well, this cosmic oddball is actually a huge help in figuring out how the universe works. For one,
M62 helps us map the galaxy. But because it's hiding behind all that dust, our usual tricks don't work so well. So astronomers use this really clever method. They measure how much the stars appear to drift sideways, and they compare that to how fast those same stars are moving either towards us or away from us. By balancing those two motions, they can calculate the distance without ever worrying about the dust in the way.
And this table is great because it shows you how science actually works. Different methods give you slightly different answers, right? But look how close they all are, hovering right around 22,000 light years. This process of comparing and refining is exactly how we build a better, more accurate map of our galaxy. And once you nail down that distance, you can combine it with the brightness of those flickering RR Lyrae stars to get an age. For M62, that age is about 11.4 billion years old. This makes it a true relic, a survivor from the earliest days of the Milky Way. So, what's the big takeaway from all this? M62 is way more than just a pretty picture. Its flickering stars help us calibrate our cosmic yardsticks. Its two generations of stars make it a perfect lab for testing our ideas about how stars evolve. Its warped shape shows us the raw power of our galaxy in real time, and its incredible age gives us a peek into what the universe was like when it was just an infant. Ultimately, studying something like M62 is a powerful reminder that the universe is always more complex, more dynamic than we can imagine. And it leaves you with this incredible thought. If just one oddball cluster can teach us all of this, what other secrets are still waiting for us, hiding in the brilliant, chaotic heart of the Milky Way?